Hi everyone, we're going to prove that 5 to the n minus 2 to the n is divisible by 3 for all positive integers n. So that means, according to the divisibility rules, that we can rewrite our conjecture as 5 to the n minus 2 to the n equals 3r for some r that belongs to the positive integers here, or just belongs to the integers. It doesn't really matter. So basically, what we're going to do is do condition 1, or step 1, and show that it works for n equals 1. So I plug in 1 here. I get 5 to the first power minus 2 to the first power equals 3. And 3, of course, is divisible by 3. Okay, so what we want to show for condition 2 is that it is valid for n equals k. So I'm going to rewrite my statement with k. And we're going to rewrite it and let this be equal to 3r. And then we're going to show that it also works for condition 2 for n equals k plus 1. So when we show for k plus 1, our statement is going to be 5 to the k plus 1 minus 2 to the k plus 1 equals 3t, and t belonging to any integers. Alright, and the first thing I'm going to do is I'm going to go ahead and subtract to make it easier this from both sides. So I'm just going to rewrite this. Looks like an S. So I'm going to rewrite this as 5 to the k plus 1 equals 2 to the k plus 1 equals 3t. Oh, not equals, but plus 3t. Now, when we come over here on the other side, what we're going to do is show that 5 to the k equals 2 to the k. I just moved it over, plus 3r. And we want it to look like 5 to the k plus 1 minus 2 to the k plus 1 equals 3t for some t. And so what I'm going to do is I'm going to multiply both sides by 5. So I'm going to take 5 times 5 to the k, because that's going to equal 5 times 5 to the k equals 5 to the k plus 1. I'm also going to multiply this side by 5, but I'm going to write it as 2 plus 3. Because when I FOIL it, I'm going to get 2 times 2 to the k here, which is going to be 2 to the k plus 1. So what we're going to get, we multiply, we get, this is going to be 5 to the k plus 1. And when you FOIL this out, you're going to get 2 to the k plus 1 plus 3 times 2 to the k. And this is this piece, plus 6r plus 9r. Alright? Now I'm going to go ahead and move this guy back so it looks like this. And you're going to get 5 to the k plus 1 minus 2 to the k plus 1 equals 3 times 2 to the k plus 12r. Now this side matches here, and I want it to look like this side. So on this side I'm going to factor out, let's do the purple, 3, and you'll get 2 to the k plus 4. Alright, so we have 5 to the k plus 1 minus 2 to the k plus 1 equals this. Now I'm going to also call this t. I'm going to let t equal 2 to the k plus 4. So basically, I have 5 to the k plus 1 minus 2 to the k plus 1 equals 3t. Now this is divisible by 3, so it holds and it's valid for n equals 1, and it's also valid for n equals 2 and equals 3, and so hence 5 to the n minus 2 to the n is divisible by 3 for all n that belongs to the integers, positive integers. Okay? That's all. Thank you. Have a nice day. Bye-bye.